In previous part of this tutorial, we created a computational mesh for steel billet and copper inductor. And in this part of tutorial, we will set up our electromagnetic problem. So first, we click on Add Physics button and select Electromagnetics module. For solver, we will choose 2D axial symmetric. Next, we will click on this button and choose for time domain to be harmonic. We can also enlarge this window. For frequency, we will set 1000 Hz, and for axial symmetry, we will select yes. And it is important that we create the geometry in XY dimensions because our symmetry axis can be only in Y direction. So next we will go to specify material properties. First, we will specify properties for billet, for which we will select a steel material. Here, lower in the boundary conditions, for billet axis boundary, we will choose axial symmetry. And for billet symmetry, we will choose symmetry boundary condition. Then we will go to air domain, and from domain time, we have to choose non-conducting. Here, we will select air properties for this domain. For air axis boundary condition, we keep axial symmetry. For air symmetry, we select symmetry, and for far field, which is outer surface of our computational domain, we will use infinity boundary condition. So the next we have to specify currents and materials for windings. And in our case we have only 4 windings. But in case if you have more than windings, then it would be inconvenient to specify materials and currents for each winding individually. Therefore, we have a tool to group windings together in one group by clicking here and clicking on Group button. So now, with this option, we can specify all boundary and material properties for all windings at the same time. So from domain time, we will choose current source, and we will set that we want 1000 amperes going through each winding. For material, we will specify copper. Now we will go back, and also do not forget that since our geometry was in millimeters, then we also need to specify millimeters here. Next, we need to add our preprocessor, which is going to be ParaView, and let's run the simulation.